Hey class, today is section 38-1 and we're examining the unit circle, but specifically just sticking with sine and cosine functions. So we're going to utilize the unit circle to evaluate common trig values. Now previously when we examined the rotation in a circular fashion with angles, what we kind of did is we said we had some sort of rotation, we had an initial side, and then this was our terminal side there. What we're going to do now is we're going to say we have some sort of point P after this rotation, and we're going to assume that the radius is going to be 1 when we rotate that. Now the x-coordinate of that point is going to be the cosine of theta, and the y-coordinate of P is going to be the sine of whatever that angle is. So that point P, instead of x, y, it's going to be cosine theta, sine theta. Now, why can't I just make that assumption? Well, let's take a look at that. So first, to be able to make that assumption, we have to examine why we are making the radius 1. So if I have this triangle here, yesterday we talked about if I have a point 3, 4, that means my x distance here is going to be 3, and then my y distance here is going to be 4, and then I could use the Pythagorean theorem to find my hypotenuse 5. Well, if I want to make the radius 1, that means I'm going to have to divide everything by 5. So 5 divided by 5 gives me 1, 3 divided by 5 is 3/5, and 4 divided by 5 is 4/5. Now let's see what happens here. If I say the sine of theta on this one, we get 4/5. If I say the cosine of theta, I'm going to get 3/5. Well, my x value is 3, and my y value is 4. But now on this one, if I say the sine of theta, this is opposite over hypotenuse, which is 4/5. If I say the cosine of theta, this is adjacent over hypotenuse, which is 3/5. Well, my x is 3/5, and my y is 4/5. If you notice, my sine value is the same as my y value. My cosine value is the same as my x value. So because my radius is 1, now I can make the assumption that those are equal and those are equal. And this is kind of like showing that. So let's find the cosine and sine values for 270 degrees and 45 degrees. So this first one, 270 degrees, well, that's this rotation here. And because we said my radius is 1, it's going to stand out a distance of 1. And so the point for that is going to be 0, -1. And so that means that the sine, if I know that that's going to be, sine of theta is going to be my y value and my cosine theta is going to be my x value, well then the sine of 270 degrees, that's my y value, and my y value is -1. And the cosine of 270 degrees is going to be 0. Now let's do the same thing for theta being 45 degrees. Now we're saying that my radius is 1. Now if my radius is 1 there, let's kind of like take a look. Why is this radical 2/2 and that radical 2/2? Why are those radical 2/2? Well, if my radius is 1, comparing this, well, this is t root 2, this is t, and this is t. Well, 1 equals t root 2. Well, if I divide both sides by root 2, I get t equals 1/√2, which is the same as radical 2/2. And so because this is radical 2/2, that's radical 2/2, and that's radical 2/2. So now my sine of 45 degrees is going to be radical 2/2/1, and then my cosine of 45 is radical 2/2/1, which is just radical 2/2 and radical 2/2. Now instead of just finding individual values here and going through that, what we can actually do is we can put all this information onto a unit circle and kind of figure out what it means from there. So we're going to look at the two triangles, or the two special triangles, the 45-45-90 and the 30-60-90 degree triangle. Now remember, the two sides here are root 2/2. This one is radical 3/2, and this is going to be 1/2. Now these are considered the reference angles. So I have a reference angle of 30 degrees, 45 degrees, and here 60 degrees. And so if my reference angle is 60 degrees, this becomes my x value, and that becomes my y value. So first, let's start by putting the 45-degree reference triangle onto my unit circle. So if I put that on here, what's going to now happen is this distance here is going to be 40 or radical 2 over 2, and this distance is going to be radical 2 over 2. So that's going to be my coordinates. Now if I take this triangle and place it into this quadrant, that means my rotation here is going to be 135 degrees because it's 90 plus another 45. So that gives me a 135 degree rotation. That's why I have that 45 degree reference angle there. Now my distance here is going to be negative root 2 over 2, and this distance here is going to be positive root 2 over 2. I can take that same triangle and put it into this quadrant here. Well, my rotation now, from here, this is going to be 180 degrees plus 45, so that's 225 degrees. My distance here is negative root 2 over 2, and this distance here is negative root 2 over 2. And I can put that triangle in the last quadrant. My rotation, that's 270 plus another 45, so that gives me the 315. And this is a positive root 2 over 2, and that's a negative root 2 over 2, and that's how I get those values there. I can do the same thing for my 30, 60, 90 triangle with a 30 degree reference angle. So with my 30 degree reference angle, this distance here is root 3 over 2. This distance here is 1/2. And I can go through and I can place it in all four quadrants. This distance is 150 degrees. That's going to be 210. And the last one's going to be 330. Positive radical 3 over 2, negative 1/2. And then if I have a 60 degree reference triangle, this distance now here is 1/2, and this distance here is radical 3 over 2. And so placing it into quadrant 2, that's 90 plus 30, so that's 120. And so I can go through and I can place it in all the other quadrants, and you get all those different values as they move throughout the different quadrants. Now the last thing that we have to take a look at are the poles. Remember, if this is like a graph, right, and where we have these like tick marks, the poles are these values here. So that means that if I'm moving over this way a distance of 1, that's going to be 1, 0. If I'm moving up a distance of 1, that's 0, 1. If I'm moving to the left a distance of 1, that's negative 1, 0. And if I'm moving down a distance of 1, that's going to be 0, negative 1. Because all I'm doing is moving over one space up, down, left, or right. Okay, you're just moving up, down, left, or right, one space. Now if I take all of that information and put it together, this is the unit circle. It has the 30 degree reference triangle, has the 45 degree reference triangle, and it has the 60 degree reference triangle, along with the 30, 45, and 60 degree reference angles. And it also has the poles here. Now remember, we also have radians as part of our unit measure. So not only do I have degrees, but I also have radians. And so we have to keep that into consideration as I do this. So here's the unit circle. We also have 360 degrees and 2 pi radians for here. We're going to have to memorize this. We're going to be given unit circle quizzes on this pretty much until we have this memorized, so just kind of understand that this is essential. It's important in calculus and complex analysis. I mean, there's so many other classes that you use these trig functions for that it's really important to be able to know these backwards, in and out. Just know it. You have to know it. But let's go over some ways to memorize this. Well, the first was the poles. Remember, we said that we're moving over a distance of 1, moving up a distance of 1, moving to the left a distance of 1, moving down a distance of 1. So that's how I get 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So that's how we get that. We just have to examine the poles. The second piece that we need to examine, let's take a look at the coordinates. So we said that this is our cosine and this was our sine. So we said cosine of theta, comma, sine of theta, right? Which is the same as our x and y. Well, if you notice, everything's divided by 2. So that's easy. Everything here is divided by 2. Third thing, everything's inside of a radical. Well, what's the square root of 1? That's 1, so all I did is just reduce it, but everything on top is inside of a radical. Radical 3, radical 2's, radical 3, right? And then so this would be negative radical 1, which just reduced into negative 1. So everything on top is in a radical. The fourth thing, look at the sine value. If we're just starting with the sine value, the top, look how it counts. 1, 2, 3, 3, 2, 1, 1, 2, 3, 3, 2, 1. And it goes around like that and keeps going. 1, 2, 3, 3, 2, 1, 1, 2, 3, 3, 2, 1. And so it keeps going around in circles in that sense. Then the next value to kind of take a look, kind of attached to that 4, is when we look at these values here. If that's 1, that's a 3. They're both 2's at the same time. If that's 3, that's a 1. That's a 3, that's a 1. Both 2's at the same time. If that's a 1, that's a 3. The next piece is the angles. So it follows the pattern of our 30, 60, 90 degree triangle and our 45, 45, 90. This is 30 degrees, 45 degrees, 60 degrees, 90 degrees. From our 90 degree, this goes up 30 degrees. This goes up 45 degrees. This goes up 60 degrees. And this goes up 90 degrees. From our 180, this goes up 30 degrees. This goes up 45 degrees. This goes up 60 degrees. And this goes up 90 degrees, et cetera, et cetera. And it follows that pattern all the way through. And then the last portion, 6 things, the radians. The first thing, if we know that this entire thing is pi, well, if I cut this into fourths, I'm going to get pi fourths, 2 pi fourths, 3 pi fourths, etc. So here, this gives me pi fourths. This is 2. Let me erase that. This is 2 pi fourths, which reduces into pi halves. 3 pi fourths, and then here's 4 pi fourths. And so that reduces into pi. Now it continues on. So, meaning 5 pi fourths, 6 pi fourths, and 7 pi fourths. So all you do is just cut it up into fourths. And as you can see here, here's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. The next thing that it gets sliced into is sixths. So here's 1/6, 2/6, and so 2/6 is going to be the same as, so if I have 2 pi 6, well, that reduces into pi thirds, and so then this is going to be 3 pi 6, but 3 pi 6 reduces into pi halves, and so now we have 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6, 9 pi 6, 10 pi 6, and 11 pi 6. And so all I did there is just cut up the unit circle into 6. And so that's a way to memorize it. Maybe another one is if you know the top portion, to find this, just understand that this value here, these are 180 degrees from each other. So if I know this pi 6 and I add pi to it, it's going to give me that extra pi 6 plus pi, well, 6 over 6 to common denominator, that gives me 7 pi 6, which is going to be this value here. So just understand that that's another way to be able to go through and do this. All right, so now how do we evaluate? Right, so this is the bigger question. How do we evaluate? How do we find the answer to this? Well, the cosine of 135 degrees, what we're going to have to do is we're going to rotate it. This is saying, is it your x or y value? This tells you how much it's rotating. So my cosine of 135 degrees is I'm rotating 135 degrees, and then my cosine value is my x value. And so that's going to be negative radical 2 over 2. For a sine of 225 or 270 degrees, my sine is my y value, rotate 270 degrees. So rotate 270 degrees, my sine is my y value. And so that's going to give me negative 1. Cosine is 7 pi 6, so cosine is my x value, rotate to 7 pi 6, my cosine value at 7 pi 6 is negative radical 3 over 2. so that's going to be negative radical 3 over 2. My cosine of 5 pi thirds, well, it's going to rotate 5 pi thirds. My cosine value is going to be negative 1/2. Sorry, positive 1/2. Cosine of 360, that's going to be my x value at 360 degrees, so I'm going to rotate 360 degrees. Well, my cosine value is going to be 1. And then sine of 450, know that we can use coterminal angles. So I don't know what 450 degrees is, but if I subtract 360 degrees, I'm going to get the sine of 90 degrees. And so the sine of 90 degrees is the same thing. It's a coterminal angle. Well, 90 degrees here, the sine value is the y value, so that's going to be 1. And then the sine of negative 30 degrees, if I have positive rotation of 30 degrees, right, this is positive rotation, well then this, starting at the 0, this would be negative rotation. So this is a negative 30 degrees right here. And so my sine value there is going to be negative 1/2. Now another way of looking at it is coterminal angle. Well, if I add 360 degrees to this, that's going to give me the sine of 330 degrees. And so once again, the sine of 330 degrees here, my sine value is going to be negative 1/2, which is going to be my answer. Well, if you have any other questions to help memorize this unit circle, I hope this helps. Please leave them in the lesson, and I will see you guys tomorrow.